Hi guys, in today's video we're going to look at stereoisomerism, cis-trans isomerism in tetrahedral and octahedral complex ions, the use of cis-platin, optical isomers, and finally an exam style question.
Well, we know that stereoisomers are molecules with the same structural formula but different arrangement of atoms, and we've met stereoisomers before. Now, with our complex ions, we have two forms of stereoisomers. We have cis-trans stereoisomers, which you'll be familiar with, and this new type of stereoisomer called an optical isomer. So let's begin by looking at the ground that we've covered before, our cis-trans isomers. So let's have a look at how cis-trans isomers can form in tetrahedral shaped complex ions. Well, in order for our tetrahedral complex ions to have cis-trans isomers, they must contain two types of ligand and they must have two of each type of ligand. Now you'll be familiar with this special little complex ion here, cis-platin. Now you can see it contains central ion of platinum surrounded by two ammonia ligands and two chloride ligands, and it abides by the rules. It has two different types of ligands and two of each. Now you can see this is the cis isomer because the chlorides and the ammonia are next to each other. They're on the same side as each other. Now cis-platin has a brother isomer. It has a trans isomer called trans-platin, and you can see here the chloride isomers are on separate sides. They're across from each other, and the same applies to the ammonia isomers. So here we have our cis and our trans isomers. Now, we said in our previous video how cis-platin was an important anti-cancer drug, and we're going to have a look at that right now. Cis-platin is a chemotherapy drug. Now, cancerous cells divide and replicate. That's how cancer grows. The cells proliferate and tumours grow. And in this process, the DNA of the cells is replicated, and that DNA replication is integral to the growth of cancer. Now, cis-platin binds to the DNA of our cancer cells, and what it does is it prevents the cell cycle. It disrupts this DNA replication and thus causes the death of the cancer-containing cells, and it actually allows the cancer cells to die, preventing the spread of cancer, and therefore acting as our anti-cancer drug.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.